Welcome back, everyone. So we're now discussing the beginning of our procedure for testing for nitrate, and this procedure begins by using this huge 1 liter volumetric flask to prepare 1 liter of the stock solution. So I'm going to show you the solid. This is potassium nitrate. We're using as a source of nitrogen. Nondescript white solid, nothing really exciting about it. I went ahead and I pre-weighed a certain amount of it right here. I'm not going to tell you how much I weighed because I want you to calculate it. What we know about our stock is we want it to contain 250 milligrams of nitrogen per liter. So what you'll need to do is start with 250 milligrams of nitrogen and calculate how much of potassium nitrate, how many grams need to be weighed. I'd like to point out that we're making 1 liter of this solution, and the concentration must be 250 milligrams of nitrogen per liter. Therefore, our solution must contain 250 milligrams of nitrogen. So the calculation you have to do is go from 250 milligrams of nitrogen, this is your desired starting point, converting it to moles of nitrogen, and then from moles of nitrogen, converting it to moles of potassium nitrate. As you can see here, 1 mole of potassium nitrate contains only 1 mole of nitrogen, so it's 1-to-1 ratio. And then knowing moles of potassium nitrate, you have to find grams of potassium nitrate. I will give you a hint, just to make sure you do it correctly. The grams of potassium nitrate you should find should be below 2. So less than 2 grams is what you need. And the exact amount, of course, is what you need to find to tell me what it is. Before we actually look at how we're making this solution, I want to talk about units. As you know, units are very important when making measurements and doing calculations. And here we're using units that are not very familiar to you. We typically use molarity, moles per liter, to express concentration of a solution. However, here we're talking about much smaller units because we're talking about tiny concentrations of these contaminants in water. They're much lower than molar concentration. So here instead we're talking about milligrams of just nitrogen per liter of solution. And my question to you is, you probably noticed that in the table we just looked at for consumer confidence, the concentrations of these contaminants are typically expressed in parts per million for everything but lead. Lead is expressed in parts per billion. But how do parts per million nitrogen relate to milligrams of nitrogen per liter? I've done some math here for you. So to remind you, 1 milligram is equal to 1 times 10 to the negative 3rd gram, and there is 1,000 milliliters in 1 liter. So if we put 1 milligram over liter, it means we're putting 1 times 10 to the negative 3rd grams over 1,000 milliliters. I wrote it wrong. Make a correction real quick. So we're talking about 1 times 10 to the negative 3rd grams in 1,000 milliliters. So if we do the math, we end up with 1 times 10 to the negative 6. But parts per million is 1 over 10 to the 6. Now compare this to this. I hope you can see numerically this and this are the same thing. They're equal. So what I'm trying to tell you that you need to sort of remember throughout this, and hopefully in the future, if you ever have to do any sort of calculation or analysis like this, parts per million of a substance or particle is equal to milligrams of that particle per liter. So we can use parts per million nitrogen or milligrams per liter nitrogen interchangeably. So going back to my solution here, so I have a dilemma. I have this solid, I need to add it to this flask, and then of course I would have to add enough water to have the meniscus right across this graduation line in the neck of the flask. But how can I transfer all this solid into this flask without losing any. You might say, well, you have to use a funnel. That's true, but then how can I be sure that absolutely everything will get transferred and none of the solid will get lost? I'd like to show you how to do it in the best possible way, most accurate way. Instead of transferring the solid to the flask, what I'm suggesting we would do, I have a clean 100 milliliter beaker here. We can dissolve the solid right here in the beaker first and then pour the solution down the mouth of the flask. This way we will avoid having to transfer the solid into the narrow mouth of the flask. So what we can do here is place this solid into here. As you can see, there is a little bit of solid left on the weighing boat. What I can do is wash it down. Potassium nitrate dissolves in water really well, so this makes it really easy. So by washing down my weighing boat, I can ensure that all the solid is transferred into the beaker, and then I can add some more deionized water to my beaker, swirl the contents around, washing the walls of the beaker to make sure all the solid is dissolving. As you can see, most of the solid has already dissolved, even though I only added about 20 milliliters of water. Do I have to worry about adding too much water? Of course not, because all of that is going to go into this flask, and then I'm going to have to add a lot more water to get to my mark to make a total of 1,000 milliliters worth of solution. So I can keep adding my water and swirling around. You might, of course, use stirring rod as well, which I didn't grab, so I don't have it right here with me. But I would also point out that even better way to do it, to avoid transferring the solid from the weighing boat into the beaker, I might have just taken the beaker, tiered it, and then weighed the solid in the beaker directly. This way I avoid transferring my solid completely. I weigh and dissolve all in one container. So I'm going to add a little bit more water. Of course, I have to make sure my solid dissolves completely. Right now I still have a little bit of it left on the bottom. Nice thing about potassium nitrate is how readily and quickly it dissolves, so I can dissolve all of the solid. I don't think I can do it without the stirring rod, so I grabbed one. I'm going to dissolve all of the precipitate, all of the solid rather, in this beaker here. As you can see now, everything has completely dissolved. You can see there's a clear solution. In case if there are tiny particles of solid still left, I'm going to add some water to my beaker after I transfer the initial solution. So I pour this in. I'm not using a funnel because this is quite a big flask and its mouth is quite wide, but funnel of course could be used. So I'm going to add some more water, rinsing down my stirring rod and the walls of the beaker. I'm going to stir some more to make sure if any solid potassium nitrate was still left behind in the bottom, that now it for sure dissolves. Pour that in. So now what I'm going to do is I'm going to add enough water so I have it to the mark, and we're going to be done with our stock solution. So before we continue, I'd like to talk to you about how this solution is going to be used. So this solution will be used to prepare standards. Standard solutions are needed to prepare a calibration graph showing relationship between log of concentration of nitrate and voltage. And so we need total of 4 standard solutions that we're going to prepare, and then we're going to measure voltage for each, which we will discuss in our next video.